Today, we're diving straight into an explainer on a crisis that literally affects every single one of us, global waste. But look, we aren't just going to sit around and doom scroll about trash. We're looking at the high-tech vanguard. We're talking artificial intelligence, the Internet of Things, and how they're actively dragging us toward what's known as a circular economy. It's a massive, fascinating shift in how we handle our resources, so let's just get right into it.
We got to start with a reality check. 2.01 billion. That is the literal tonnage of municipal solid waste the world pumps out every single year. Over 2 billion tons. And with populations booming and economies expanding, we are just producing a staggering amount of trash. The truly tragic part here, at least a third of this waste doesn't even see safe environmental management. It ends up openly dumped, or worse, leaking right into our oceans.
And honestly, nothing sums up the absurdity of this quite like the number 12. 12 minutes. That is the incredibly short average working life of a plastic bag. Just think about that for a second. We extract ancient fossil fuels, process them into synthetic polymers that'll stubbornly sit in the ocean for maybe 20 years, all to carry our groceries for 12 minutes. 1 million times a minute globally. It's wild. It is the absolute ultimate symptom of our current economic model.
And that broken model, we call it the linear economy. You take raw materials, make stuff, consume it fast, and throw it away. It's just a straight, depressing line to a landfill. We absolutely have to ditch this failing extraction and disposal method for a restorative, closed-loop vision, the circular economy. The whole goal here is to design waste out of the system entirely and keep resources moving in endless loops. To actually pull this off, experts lean on something called the 10 R's hierarchy. Right at the very top, the absolute holy grail of preferred strategies is refrain or refuse. Basically, just avoid using the resource in the first place. Right below that is redesign and reduce, meaning we engineer products from day one so they just require fewer materials, and then reuse, simply repeating the use of an item to stretch its lifespan as long as possible.
Now, moving down that hierarchy, the strategies shift toward keeping those technical and biological materials circulating in the economy. If you can't refuse it or reuse it, well, repair and refurbish it. If it's totally beyond repair, remanufacture or repurpose it into something else entirely. And then, finally, at step 6, we hit recycle. Kind of crazy, right? Recycling isn't step 1. It's actually pretty far down the wish list.
And here's the real kicker. What we typically think of as traditional waste management, strategies like recovering energy through incineration or just dumping things into a landfill, those sit at the very, very bottom of the hierarchy. They are the absolute least preferred approaches. They carry this massive environmental footprint, and once a post-consumer product goes there, it's essentially gone, lost to the system.
Okay, so that hierarchy sounds awesome on paper, but let's be real for a minute. Moving away from traditional collection and landfills is brutally expensive and intensely complicated. Changing human habits takes time, and processing mixed garbage into pure reusable material is a logistical nightmare. Which really begs the question, how on earth do we practically enforce this circular vision without just bankrupting municipalities?
Well, the answer to enforcing this whole shift lies in technology. So let's explore the high-tech future of waste management.
Specifically, let's talk about collection. For decades, cities have used these fixed schedules for garbage trucks. A truck drives its entire route, emptying bins whether they're overflowing or completely empty. Honestly, it's incredibly inefficient. But now, we're hooking waste management up to the Internet of Things, or IoT. By utilizing connected sensors and data platforms, we're turning dumb, ordinary trash cans into highly intelligent data points on a real-time city grid.
Let's look at how this plays out in practice. Cities are deploying these smart bins equipped with actual capacity sensors. They ping their exact fill levels back to a central platform. So instead of a truck driving blindly, its route is dynamically generated in real time to only pick up bins that are actually full. That saves massive amounts of labor, time, and diesel fuel. Plus, these bins are fitted with methane detectors, constantly sniffing for gas buildups to alert teams and avoid some seriously hazardous accidents, especially in the summer heat.
All right, so the trash gets collected efficiently. Then what? Once it arrives at a treatment plant, artificial intelligence steps in. Now, sorting garbage manually is slow, dangerous, and prone to human error. But AI-driven machines, they use computer vision and deep learning algorithms to sort recyclables insanely fast. The AI instantly differentiates between materials, catches tiny nuances among plastics, and can even sniff out chemical contamination.
To really get a sense of this, let's look at a dynamic real-world pilot, the full-scale ZenRobotics treatment plant down in Barcelona. Just picture a rapid conveyor belt covered in a chaotic, messy mix of garbage. Hovering right over this belt is a robotic sorting system packed with high-tech sensors, lightning-fast robotic arms, a camera, and a metal detector. As the waste just zips by, the camera and sensors visually identify every single item in a fraction of a second.
The physical sorting is honestly mesmerizing to watch. Guided by that AI computer vision, those robotic arms instantly recognize and separate 13 distinct materials from a single layer of waste. It effortlessly plucks out high-density polyethylene, that's HDPE, PET plastics, ferrous and non-ferrous metals, wood, cardboard, Tetra Paks, and it's doing all of this at speeds manual human labor simply cannot compete with. But the true game changer here is the accuracy. In that Barcelona pilot, the ZenRobotics system achieved an astonishing average of 90% purity across all 13 of those sorted materials. 90%! And that is just from pulling from a single layer of waste on a moving belt. This level of purity is absolutely crucial because if you want to actually reuse materials in a circular economy, they have to be cleanly separated without any cross-contamination.
So ultimately, AI isn't just some flashy tech gimmick. It's a vital economic engine. Like we talked about, transitioning to a circular economy is inherently expensive, but AI and IoT allow waste management companies to radically reduce those manual labor costs, save fuel, and maximize efficiency across the board. We are finally building the high-tech infrastructure necessary to pull valuable materials out of the trash and redirect them back into the economy profitably.
Which brings us to a final thought. The technology is already here. Between AI sorting facilities in Barcelona and IoT smart bins routing trucks in our cities, a high-tech circular economy isn't science fiction. It is possible today. But technology is only half the battle, right? The rest falls on us, sitting at the top of that 10 R's hierarchy. So, knowing that these crazy advanced systems exist to capture and recycle what we use, what changes will you make to stop feeding the linear waste machine in the first place? Definitely something to chew on. Thanks for joining me for this explainer, and I'll catch you next time.